let's continue on here. Any questions about that? Any concerns about that? Let me ask this, folks. Suppose I didn't want it to interpret path. I didn't want it to interpret this as a. Suppose I didn't want to interpret this this thing to turn it into something else. Maybe I want to look for $home here, right? Maybe I want to look for that in foo.text bar. Maybe these are shell scripts or something like that. I want to look for this thing. If I give it this, what's going to happen? Is it going to look for $home in these things? What is it going to look for? Yeah, it's going to look for in my home directory, sort of a pointer to my home directory. So where my home directories will substitute that in. Because this is called a what? Yeah, it's a shell variable. An environment variable in this case, because it's accessible to multiple things. So, so we have that. So if we want to prevent that, what do? Okay, close. If I put this, is it good? No. Because it still looks through these sort of quotes. These sort of quotes, it still pays attention. It knows it's all one thing, but it still substitutes the exhibit. So we need single quotes. And that's the ticket. Okay. That will keep it from interpreting that. That's a useful factoid. And it may be useful tomorrow. Okay, so question about that. So part of the issue is when you're issuing these commands, you've got to be sort of attentive to sort of what the shell could interpret, what could it be paying attention to, what could it misunderstand, and guard against it by putting sort of putting quotes around it. Even if you don't think you need it, it's kind of good practice to do. Okay, so we talked about a bunch of commands, and I'll just spew them up here, and you can ask me questions about them if you'd like. ls, what does that do? Yeah, it looks at the contents of the directory. How about cat? Yeah, prints contents out, for example. More? Sorry?
Prints out contents.
Some scrolling options so that you can look at page by page by page, for example. Good. How about empty? Crucifix. Good. How about echo? Yeah, prints simply the standard output CP. Copy RN. Remove. And then connector. Makes a directory. Okay. Now I should note, folks, that one could be lulled for those who have grown up in other operating systems. Perhaps, for example, grown up using Windows or something like that. These things may look very familiar to many of them. After all, you have a board, for example, there. You have a echo, if I'm not mistaken. You have something equivalent to CP called what? Called copy. So you have called copy. But you have to realize the semantics are different. The meanings of some of these are subtly different. I know one guy, good friend of mine, who was operating on a Windows box one time. He was operating Windows boxes most of the time. And then he went to a Linux box, and he wanted to copy a bunch of files from a certain folder to a certain folder. Now, on Windows, if you say copy, C:\\foo star.txt, and you just issue that, what happens? If you're in another folder and you say this, what happens? Well, it actually goes and expands this. It finds the star.txt, but because you've omitted another option here, it just copies them to your current folder. So it goes, hey, go get those and bring them here. That's the semantics of it in Windows. If you say this as CP in this sort of way, and forget about the C:, because it's all one unified system in Linux. If you say this, what happens in Linux? Well, it will actually expand this. And suppose this is two files. So copy one, for example, over the other. So, that's not so good a thing. And he lost a major file because of this. I mean, he had a really valuable set of files, and one destroyed the other. And I think he ended up spending a day trying to recover from that or something like that. So they are different. I'll tell you another thing that's different. I kind of muttered it, but it's worth noting. Typing. Foo, type into bar. How is this? Is that the same? So if we type a program foo into bar, let's suppose it's cat and we pipe it into WC. Does this work in Windows? Can you do this in Windows? Actually, it turns out you can. But the semantics is different. In Linux, if I do this, I can then type interactively and it's counting up the word. This is not a great example. Doing it to unique is a better example. It'll actually be printing out interactively as unique lines come. In Windows, what happens is this command has to complete before this command can go. It will give all the output from this command to this command after this command is done. So it actually runs them not in parallel but separately. So that's just a factor. I can't remember. I've mentioned that before in class. It's one of those things I was thinking, did that sink in? And I can't remember if it's on the exam, to be honest. Okay. File directory command. What does CD do? Change the directory. PWD. That's the present working directory. The current working directory. Well, we talked about the others, so that's fine. Okay. So that's good. Okay, we talked about more. How about less? Sort of. What does less do? Give me one salient feature less gives you beyond one moment. Scroll back. So that's one of the most common, certainly for me. I do less, so I can scroll backwards, not just forward. So page by page by page, forward, and then page back. Because I press spacebar one and something like that. Okay, how about diff? And particularly it's aimed at text files. But ladies and gentlemen, diff is one of the more useful programs you'll encounter on Linux. So if we say diff a.c or rig.c, the root version of this, it will show the differences between the two. It'll say, oh, that a.c, for example, has a line inserted in text that was originally from this. It says, this one line was inserted here within the text of a.rig.c. So it tells you the changes. It doesn't show you both in their entirety. It says, hey, they're different from one another in this way. This line got deleted. This line got added. This line got changed, for example. Or this whole section got deleted. It'll tell you that, okay? And it has a special syntax for it with greater than characters and less than characters. But this is one of the more useful things. The command CMP, anyone know what that does? Yeah, compares, are these files the same? Yes or no, for example, for binary data in the same file. WC? Word counts the number of characters, the number of words, the number of lines, for example. Sort, well, sort of self-explanatory, sorts the text in a textual fashion, folks. That's not the same as a numeric fashion. If your program has in it the lines, these review sessions, yeah, I always think I'm giving you an unfair advantage. Yes, question?
Just on class, you look up the man pages when you're looking at that.
Yeah. So when you're doing man, is it secret?
When you man pass, you're actually using less.
Right. Well, you're using that functionality. I actually don't know if it's implemented that way, if they just reproduce that functionality separately in man. I think it's a separate program. I don't actually think it's using the actual program less, but it's the same basic functionality. Yeah. Yes. I love these books.
There was one question for
Yeah.
What would be like the easiest way to like that question? Because someone told me like one way you do it would be make like a new file and then compare the two files with the sort of file
Mm-hmm.
against the original file.
Right.
Would there be a way like sort of one file and then compare it to the unsorted file with the
You could, okay, so in other words, would there be a way to without creating a file, for example? Yeah, so you should be able to do, and I'm pretty sure this works, so you don't have to remember before that, but I think, you know, you could sort a.txt, right? It's sorting this file, and then you could pipe it to diff and give it a.txt as an argument. And I think it could take this other one from standard input. It would compare, therefore, what it's getting through the pipeline via standard input from a.txt. Does that make sense? The other thing you could do would be to, you know, sort that I think was suggested to you, a.txt, and make it, you know, a sorted.txt, and then do a diff of a.txt and sorted.txt. But this is actually more parsimonious. It doesn't, you know, fill your directory with cruft like this a sorted that is only a transitory need. It's only, you only need it to do this comparison, that's all. So this doesn't litter, doesn't pollute your namespace. Does that make sense?
Yeah.
Yeah. So it's a good question. By the way, what is this called? Diff gets its what from sort. It's what is provided from here. It's, yeah, standard input. Standard input. All programs have three all Unix programs have access to, console programs have access to three basic streams. What are they? Standard input, standard output, and standard error. Right. And standard output and standard error are output streams that go out, and standard input comes in. Okay. And we didn't talk about it in class, but it turns out you can redirect even standard error, so it goes in the same stream as standard out, for example. There's ways to do this, and in your book it actually describes some of those ways. You should just be aware that all programs take all three streams. Okay, so that's good. Okay, so unique. What's the function of that? Good. Excellent. Well spoken. Head and tail. First 10, last 10, or last number one. Okay. DU and DI. What's the D stand for? Disk. Okay. And what's the different function? Sorry? Yeah. So one gives disk usage, sort of how much space you're using on disk at different parts of your file system, and the other gives sort of where things are mounted, sort of where different parts of the file system are coming from, what external machine. Remember that the file system on Unix, like, you know, your student / your NSID or whatever, it's all part of one, sort of what looks like one big tree. So you may have, you know, faculty here, and you may have, you know, students here, and maybe there's grad students and undergrads. There's not in our particular one, but there's undergrad students, and each of those have things, and then maybe, you know, /bin is up here, and in contrast to Windows, where we have like this disk, you have that disk, and we say C:, whatever, D:, whatever. In Unix, you can mount any of these. Like this could all be coming from one machine. This could all be coming. This could be coming from one machine. This guy can be on another machine, and they're all meshed together, sort of seamlessly. Okay. So those are some commands there. So I'm gonna just comment on